reciprocal curve. It's a base curve. So what you would want to do here is put this in cosine mode. Start like this. And actually, probably if you pull it out here, it's a little bit better. That means you're going to do half the curve in 2 pi. And like Amanda said, she expanded it to 4 pi because that's a full cycle. If you do the negative and the positive, you still get a full cycle. So whichever way you do this is fine. So your cosine curve is going to start here, come through here, would come through here, come up here. Let me go to 4 pi in case you did 4 pi. And come up here. Here's your cosine curve. So off your cosine curve, you're going to tell, where's the zeros? The zeros can happen. And right away you can see at pi, at 2 pi, at 3 pi, there's your cycle. So at 1 pi it doesn't work, at 2 pi it doesn't work, at negative pi, at negative 2 pi. So your cycle says, whoops, your cycle says every n pi, where n is any odd integer. Oh, this is 3 pi. Sorry, this is 3 pi. At pi, at 1 pi, at 3 pi, at negative 1 pi, at negative 3 pi. So I can kind of see my cycle at any odd integer. Now, it's very hard to graph this without going through the cosine curve. I mean, it's doable, and you can put it in your calculator. It'll work, but you got to get your period in there. Get your period, same way you did the other one. 2 pi over b, 2 pi over 1/2, keep change flip, 4 pi. If this is your period, don't forget you have to go through 4 cycles. You got to divide this by 4. Every pi is where you put your tick mark. Every pi. So if you're going to put this in your calculator, this has to be where your scale is. This has to be your change of table. If you did pi over 2, obviously you're going to see them. You'll just see a few extras, and that's fine. Now, a nice way to do this is to say this. The secant, and this is what we didn't do on Friday, but I wanted you to get to graph this. The secant says my domain is all real numbers, except it's like the tangent when x is n pi over 2, where n is any odd integer. This is my regular secant, right? Take this and set this equal to this. Okay. Quick way to find the domain. But I wanted you to find them on the graphs first. Because if I give them to you, then you just set the asymptotes up and your graph is there. So you take this guy, x over 2, and you set it equal to this. And you solve for x. So if I cross multiply when my denominators are equal, aren't my numerators equal? So I don't really have to cross multiply this, right? I can just go like this. So x is equal to n pi, but you have to keep this, where n is any odd integer. Okay, you keep the original saying part of it. Would it ever be even? Yeah. Yeah, but in a regular cycle. You know, if you're doing like cotangent, cosecant, where it's every even integer, even? No. Yeah, no. It could, maybe it could be on a 2x. It could, no. Because we either do every integer or every odd. So it won't be every even. It'll be every integer or every odd. Take whatever it is the original one has. The cosecant and the cotangent do every integer. Okay, but I wanted you to graph this without doing it this way, because these are where your asymptotes are, right? Because those are your exception parts. So then you'd graph your asymptotes at 1 pi, at 2 pi, negative 1 pi, negative 3 pi. That's how you would graph that. So you can do this without graphing your cosine curve. And remember, your range is exactly the opposite of your cosine. Your cosine uses negative 1 to 1. Your secant and your cosecant use negative infinity to negative 1. 1 to positive infinity. They're the opposites of the middle part. Okay, so give me the domain, give me the range, and a little sketch. So yes. Okay, tangent. The tangent says, give me half of my curve in, not in 2 pi, in pi. Your tangent cycle is pi. Remember we did that last week, Friday? We said tangent works different than your cosine and your sine curves because they're not a curve. They're broken up by asymptotes, and the 90 and the negative 90 don't work. So your cycle is 180, every 180 degrees. So now, if I want half of my curve in 180, how long is it going to take me to complete my full curve? 360 or 2 pi. So now I'm going to go, instead of at the 1/2, at the negative 90 and the positive 90, and I got to still be centered because the tangent of 0 is still 0. There's my asymptotes at the pi and the negative pi. So tangent, we start like this. So here's my 90. Normally my curve is in here at the 90s, but because I'm going to full 2 pi, here's my curve now at the 180s. And all you're going to do is just make this little piece of spaghetti thing to go through. Just make your little piece of spaghetti. A little squiggly line there. It's not a continuous curve. Amplitude changes don't affect your range at all because it's not a curve. It's forever and ever. Your domain stops at the asymptotes, but your range says all real numbers. So
every odd pi.
And if you did this, you would say negative 1 pi, positive 1 pi. So my next one would be what? From here to here, I went pi. What would I go to next? 2 pi, 3 pi, 4 pi. Because I'm going to go every pi. No, I'm going to go every 2 pi. So 3 pi, sorry, 3 pi. So every odd. And again, take this one. Take your tangent. Your tangent says the domain is all real except when x is equal to n pi over 2, where n is any odd integer. You got to have this little qualifier in there. Take this and set it equal to x over 2. And again, the denominators are the same. There's your numerator. But you got to keep this. So your domain says n pi, where n is any odd integer. Because now your period is not pi, it's 2 pi. So you got to skip over 2 pi. That's all we did was change your period.
So that second curve that was on the 2 pi?
This is crossing through the 2 pi.
Yeah.
That's crossing. So at the 3 pi would be your asymptote. These give you your asymptotes. Because those are the things you can't put in your domain. Okay, now this tangent works the opposite. If this tangent expanded that, stretched that, this one shrunk that period. So what is the period of pi again? The period for tangent? Just pi. So now, if we have the tangent of 2x, that means I need to fit 2 curves in pi. So well, 2 pieces. So how long is each little piece? Half of pi, pi over 2. Every pi over 2. So we start like this. Every pi over 2, give me an asymptote. That's where my things are going to go to. So every pi over 2, just take, and if you do that, take your pi over 2s, divide them into halves again, because that's where your pieces are now. So here's your asymptote. Here's your, whoops, got to go across here. Every pi over 4, sorry. Get rid of that one. Every pi over 4, I should use this 2 different colors. I'll just make a little tick mark. This is 90, this is negative 90. So every pi over 4 is where your graph is going to go. Because your regular period is pi, so now your period is going to be pi over 2. So you got to put pi over 2, 90 degrees, equal distance from the 0. Because it's still going to be tangent of 0 is still 0. If I say, what's my tangent of 0 in here? Even though I do 2 times 0, I'm still 0, right? So it's always kind of centered here unless you have a shift somewhere. We have no shifts. No phase shift on this. So we still start here. So you're going to have to go out pi over 4, go over pi over 4. So the easiest way is just to take these and go every 9 and divide your 90s into pi over 4. And do it again over here. Make all your pi's over 4.
Wait, so would there be a curve that crosses through like pi over 2, pi, and pi over 3? And makes that
For this guy, no. It would have to be odds. This would have to be odds because don't forget, you're centering this. What is the tangent of 0 for this? We have no shift anywhere. There's no phase shift. So your tangent of 0 still has to be 0. Let me do 2 different colors on here. Here's your 90s. This is normally where your tangent curve goes, isn't it? Right here. So I need to make 2 of them now. I need to put 2 of them in here. But I still have to go through the 0. So I'm going to cut this in half and start it here. And I'm going to have to do another one. It's going to have to change this every 45 degrees. I'm putting this little asymptote instead of every 90 degrees. Because you still got to go through the 0. So let's take a look at this piece right here. Your tangent says n pi over 2 where it's odd. It's still going to have to say odd integer. Set this equal to this guy. So 2x is equal to n pi over 2. Cross multiply and then divide by 4. Do you see it? Isn't divide by 4 every 45 degrees? Or every 45 degrees where it's an odd integer. So 1 pi over 4, 3 pi over 4, 5 pi over 4. We did the negative 1 pi over 4. So the next one you're going to get is here. And you're going to do it again.
You would so you go every 90?
No, every 45. You're going every 45. You changed your cycle. But every odd 45. If you did an even 45, you'd go over the 9. You do every single one of these. That's where your asymptotes are. That would never make sense. You can't go every one. You have to go every other one. Doesn't this go every other one when we do a regular tangent on 90, then it skips the 180, then it does the 270, then it skips the 360, then it does the next one. It skips one. It has to skip one. So what happens here is we skip the even ones, which is pi over 2. So isn't pi over 2, don't forget now, isn't pi over 2 have a 0 now? It's the odd ones where the asymptotes are. That's where your asymptotes go.
Wait, so which ones are your asymptotes on? Pi over 2?
Whatever this comes out to be, where your exception is where your asymptotes are. So the best way to start is take a graph. Start with your beloved 90s. You have to cut it into every 45. So start like this. These are all 45s now, right? Yeah. Your tangent starts at the 0. So count your 45s. Here's your 1, here's your 2, here's your 3, here's your 4, here's your 5, here's your 6, here's your 7. Then go the other way. There's your 1, there's your 3, there's your 5. And in between here is where your curve goes. Like this. These are your asymptotes that you say all real except. When you say except, that's an asymptote. Don't forget, the regular tangent can't do 90, but we're not using the regular tangent. We're using 2x. We're saying, I want 2 of these inside of what you normally put 1 of these. So if you just kind of look at this section right here where we did negative 90 to positive 90, I get 2 of them in there. The tangent works a little different because it's not a continuous curve. And before when Gabby said, are we going to ever get an even? We're either going to get an odd integer every odd or every integer, because those are where your basic domains come from. But I didn't want you to do it that way with your homework. I wanted you to think it out with your curves. And then that's exactly what you should have found. What's happening to my curve? It's going 45. Then I do cross over the 90. Then I hit another 45. Then I do cross over the 180. Then I hit another 45. Where are my asymptotes? Oh, so it's pi over 4, it's 3 pi over 4, it's 5 pi over 4. All my odd ones. So that when we did this, you'd say, oh yeah, that's what I found. The reciprocals and the tangent, well, the reciprocals aren't as bad as the tangent. The tangent and the cotangent, I find the cotangent to be more confusing because the cotangent is the opposite and it goes the opposite way. I find the cotangent to be a little bit more confusing, but I don't think you guys worked with tangents at all last year. If you would have worked a little bit with tangents, usually teachers work more with tangents and not cotangents, but that's okay. So this guy works off of a sine curve. So make your basic sine curve, which is how you should have done this, right? And so get your basic sine curve in here somewhere. I think my graph is off. So here's your basic sine curve. I think this is off over here. This one's off. Don't look at that side. So now, we didn't change your period. Your period is still 2 pi. What we did change was this, your amplitude. So instead of your sine curve going from -1 to 1, it went from -2 to 2. Therefore, the only thing that's going to change here is your range. Your domain is going to stay exactly the same. And again, it can't cross through these zeros. When we take a 0 and we take its reciprocal, we can't do that. We can't divide by 0. So any of your zeros are where your asymptotes are going to be. Those are your exceptions to your domain. So again, at the 0, at the 1 pi, at the 2 pi, at the 3 pi, where x is n pi, where n is any integer. And those are where your asymptotes are going to be. Those are your exceptions to your domain. The only thing we changed here was your range. Stop me if you have any questions. Okay, cotangent, a little different here.
Yeah, I didn't get it as a pi.
Okay, so, and I didn't really want to give you this time, but this is where it goes back to radians, which means this was probably hard for you to grasp without doing this rule. So let's start with this one. Let's take this. Now cotangent says it's the same thing to C. It's like a cosecant, where it's all real numbers except for x is equal to n pi, where n is any integer. So start with this. This is where I did these last year, but I decided not to do them with you this year because everybody was struggling because you didn't really have a good of a background. So I decided not to do. I don't think you guys did much in radians at all. So I didn't want to throw you off. I didn't realize these were both in this one too. This one, the next one too. So when you cross multiply these, so let's do them out the long way. I'm solving for x. I'm going to get rid of pi. So x is equal to 2n, and again, where n is any integer. So that means 2, put a 0 in there, 0, 2, 1 times 2 is 2, 2 times 2 is 4. They're all going to come out to be even. This is where the even part comes from. Because you're just going to take your integer, multiply it by 2. These are in radians. So this says to me x is equal to 0, 2 times 0. I have a, so x is equal to 0 radians, it's still at the 0. So here at the 0, I have an asymptote. When x is equal to, if n is equal to 1, I'll just do a couple of these. If n is equal to 2, these are at the radians. So 2 is about, pi is 3.14, so 2 is probably like, pi over 2 is 1.57. So it's between pi over 2 and 2 pi, something like that. Between pi over 2 and pi, somewhere around there. So if this is where my pi is, it would be right before it. It's in radians. So is your graph. When you graph pi over 2 pi, that's in radians. So when you put this in your calculator, remember when we put radians in your calculator and we looked at your table, everything has a decimal? It just converts it to a decimal. That's all it does. It just actually does the divide using 3.14 as pi. So pi, which is 180, is actually about 3. Pi over 2, if you divide 3.14 divided by 2, it's like 1.57 or something like 1.6. So somewhere between here would come the 2. That's where your asymptote would fall. I'm not going to hold you responsible for those. I realize you guys didn't do much in radians and you probably didn't get the concept. But every once in a while on that Algebra 2 Regents, they gave you an angle. Did you see them when you reviewed? They gave you an angle and it said 2 radians and they wanted you to graph it. No one saw those?
So should we graph this?
I won't hold you responsible for this because I said I wouldn't. And the next one has the same thing. I did last year. I did these. Because you guys did. You're my first Common Core group. So we're still struggling where it was Common Core. We're not going to go based on what you had to learn to catch up to the regular trig because you're never going to see I'm never going to see regular trig kids again. I'm only going to see Common Core kids again. So we're still struggling. Every time we get together, the other pre-calc teachers, we're still struggling because you did squeeze those in at the end. So some did, some didn't. So right now we're kind of still not sure what we're going to get. Hopefully next year will be only Common Core. I don't think they're given the regular Regents this year. I'm not sure. They're not supposed to, but who knows? The state could come back like they did with the Algebra 1 Regents. They gave it for like 4 years. And they kept saying, well, if they're in the cohort, so it's like, what cohort? So I'm not really sure where you guys stand on this. So you can get rid of this one too. This one is also in radians. This one should not be. Okay, so this one, all the difference here is this negative sign. So if you start like this, it makes your life a lot easier. So sine normally starts at the 0 and goes up 1, down 1. But now you're going to reflect this and start at the 0, then go down before you go up. For some odd reason, I went to 3 pi here. So this is 2 pi, this is 1 pi. This is pi. I probably copied it out of the book because I would never do it like that. Okay, so your sine curve is just going to drop down instead.
Do you just cancel the 0, 1, everything by -1?
Yes. Just do your points like this. Just take these and just multiply them by -1. That's all that it does. If this had been, I would multiply them all by -2. The amplitude is still 2, and the amplitude, God bless you, is still 1. But the reflection is the negative. So if you multiply everybody by the negative with this, it automatically reflects it. So start that way, the way you know and love, and then draw your curves. Your cosecant curves. And again, we didn't change your domain, so your domain remained exactly the same, which you could see every pi, 2 pi, 3 pi, negative 2 pi. And all that changed is just the graph part. Your range didn't change at all. Okay. I wanted you to figure out your domains without this. Here's another one. Where 2 pi n. This one you should have been able to do, right?
Yeah.
This one wasn't so bad. Because the period is changing. So your period is, pull this out this way. So your period changed. So your period says, I want half of the sine curve in 2 pi. So it's going to take me 4 pi to make a complete curve. Or extend it to do the -2 pi. At least you get to see 2 pieces, a top and negative and a positive of this. Try not to graph just one piece like this when it's a 4 pi. Just kind of extend it somewhere. Either go to 4 pi or go to -2 pi. Because technically, this is your full cycle. This and this is one full cycle. If you just gave me from 0 to 2 pi, that's only half your cycle. So I don't care if you come out to 4 pi, bring this out to 4 pi, and then do it off of here, bring it down there, bring your sine curve out. As long as you give me a full cycle. And going to 4 pi is probably easier. Every 2 pi, where n is any integer. It still is where n is any integer, but that 2, that's what gives us the even one. Because didn't you double? We doubled everything. You said instead of going to 2 pi, go to 4 pi. And your range stayed exactly the same. And again, all you have to do now is take this and set it equal to x equals this. Because algebraically, you can find your domain here without having to count here. But I wanted you guys to find it here because if you do this, you automatically find your asymptotes, and then that's all you have to do is plot your asymptotes down and get your graph in between them. But I wanted you to kind of find those yourself. And there it is. But you keep the same n is any integer. And so if I was doing that, I would say, okay, at the 0, at the 2, at the 4, drop me a thing and just plot me a curve in between there. I would do this. Here's my 0, here's my 2 pi, here's my 4 pi. Oops, somewhere halfway, there's my curve. There's my curve. That's all I would have to do. But I wanted you guys to think this out, to find it. And it'll totally make sense when you understand that part of it now. Cotangent. Now remember, your period for cotangent is like your period for tangent. It's not a continuous curve. Your period is pi. So if I take a half of this in pi, that means I need 2 pi to complete this curve. So then I need another one, 4 pi. Remember, your tangent is different. Your tangent goes through the 0. Your cotangent does not. Your cotangent goes through the 90. So now if I double 90, I'm going through the 180. It's easier to graph when it's this way because it doesn't start, the asymptotes are here. So if I take this, watch, I write my cotangent curve, x is equal to, I just take this and I say x over 2 equals n pi, where n is any integer. I can start my cotangent like this. These are my 90s. So at the 0, I have one. If n is 0, what is x? 0. If n is 1, what is x? If n is 2, what is x? 4 pi, right? Every 2 pi. I'm still going every integer. That's what's giving me my even. I would just do this. Here's an asymptote. Here's an asymptote. My cotangent has to go halfway through it like this. Then do this another 4 times. Here's an asymptote. My cotangent has to go this way. My tangent goes this way. My cotangent goes this way.
So cotangent never goes through 0.
Because the tangent of 0 is 0, so 0 over 1 can't work. It's the opposite of your tangent. We can't say never on this because if you shift the other way, if you have a shift, a phase shift, then you can, but we don't have a phase shift on this. We hopefully will never see a phase shift on this. Okay? And that one wasn't too bad. And this last one, here's another one.
Yeah.
Alright, so I won't give you this one either. Just know that if we do, and it's odd, like just put numbers in there when n is 0. What is x? That is 0. That's an asymptote. So I'm going to start with that. If I put, only odds. Sorry, no zeros. So if I put an odd number in here, 1. So 1 times 2 is 2. 2 again, pi is 3.14. Pi over 2 is 1.57 something. So somewhere in between there is a 2. Okay? It's not going to follow your 4 quadrants because the radians are a little bit different. But so I'm still off somewhere. So if I want to just number my graph, if I'm going to do it this way, I could number my graph in total radians. This is still in radians. This is 1, 2, 3, 4. This right here would be just about where pi is. But if you're going to go to radians, you can label everything in radians. So that I don't confuse you, because you didn't do any of this last year, I won't give you this year. But if you're going on to calc, you're going to be converting a lot of those into radians. Hopefully we'll kind of figure out what is going on between. This 1/2 going to affect my range for tangent. So what's my range still going to be? All real numbers, negative infinity to positive infinity. My regular tangent curve says the domain is real numbers except when n is n pi over 2 or n is any odd integer. Make sure you say this. So all I want you to do is take this and set it equal to this.
Wait, so we have to write it twice?
What do you mean twice? This is the regular tangent.
So you want us for the regular one and then the new one?
Yeah, because you need that to get to the new one. You're not graphing these. You're just taking this. How would you get to this one if you don't set it equal to this?
I don't know how to do it. Yeah, I don't get why you said, like, how do you, where did you get
But we were just doing that on your homework.
I know, but I don't get it.
So start with your regular tangent. What is the domain for tangent? The domain for tangent says this. Isn't it every 90 I can't use? The period is 180, right? So every this, then I can use this one, but I can't use this one. So this is 1 pi over 2, this is 2 pi over 2. Oops, I can't use 3 pi over 2. Oops, I can't use 5 pi over 2. So my regular domain for tangent says all real numbers except for every n pi over 2 where n is odd. That's my normal domain. I don't care what this looks like. All I want to do is set it equal to this and solve for x. So the denominators are the same. My numerators should be the same. I'm solving for x. X equals n, but n, any odd integer. So when x is 1, these are radians. When n is 3, they're radians. It's going to be right by pi. They're radians. I'm not asking you to graph it.
So
Well, if I was going to graph this in radians, I would put my whole graph in radians. But you guys never did that. I would graph my whole graph in radians. I'd put my asymptotes here, and I'd make my tangent curve. That's how easy it is. Because why would I bother putting all my angles here when I had to convert them to decimals, radians? Right? And pi is 3.14, so you'd be right at pi. You'd be real close. You'd be real close, right? So that I don't confuse you, I don't want you to graph it. All I want you to do is use the formula. This guy, what is the domain for cosecant? All real numbers except what? N pi, where n is what? Any integer. All I want you to do is this. Set this equal to this. Cross multiply and bring down this qualifier and find the range. That's all I want you to do. Actually, what did I do? Actually, the back page is the same as the first page, so you only have 2 more to do on the front page. Third period?